Hi, my name's Enrik Maci, and this is a short presentation I've made to supplement the results section of my fourth year project report. The main aim of this presentation is to demonstrate some animations of the simulated datasets I've been able to generate as part of my project. So, in terms of the contents of the presentation, I want to briefly summarize the model that I use to generate vehicle actions, and then I'll show the animations for the crash event I've attached in my report, and then three more animations corresponding to crash event types 1, 2, and 3, which I've defined in my report, and then animations for some near miss events and animations for events which are neither near miss or a crash event. And finally, I just want to show the complete animation for the NGSIM dataset and the around the dataset. So in terms of generating vehicle behaviors, this top probability distribution up here is used to generate vehicle actions which avoid collisions between vehicles. So this would be accelerations and lane changes based on the state of the vehicle at a given time. And then this bottom distribution down here would be used to generate vehicle paths, given that we know where the vehicle is and we know where it wants to go. So as for the case attached to my report, the animations are shown on this slide. So first off, one thing to note about this is all three animations here have the same initial state. And then if we start on the left-hand side, these are actual vehicle actions which were taken in the dataset itself. And then moving over to the middle animation over here, this is a simulated dataset using the same initial states as the left-hand animation, using the learned probability distribution, which generates actions based on the states. And then, as described in my report, we modify this action distribution over here using reinforcement learning to generate this modified distribution over here. So ideally, this would increase the rates of corner case events. And as shown here, we get a crash between the following background vehicle and the eagle vehicle over here, since the background vehicle is traveling too fast at the start of the simulation. So three more crash events, which are shown on this slide, correspond to cases 1, 2, and 3. So case 1 is a one-dimensional crash event where both vehicles are in the same lane at the start and end of the simulation. So as we can see, vehicle 4 starts off at a lot higher speed than vehicle 1, and it tries to slow down its speed before it collides with vehicle 1, but it can't do so in time, and this leads to a rear end collision between these two vehicles. So case 2 corresponds to a lane change and then a crash event. So as we can see towards the end of this animation, vehicle 1 cuts in quite sharply in front of vehicle 3, even though vehicle 3 is traveling a lot faster than vehicle 1. So vehicle 3 can't slow down enough to avoid this collision before it happens. And finally, on the right-hand side, we see a crash event where vehicle 2 moves over 2 lanes to the left before it collides with vehicle 1. So as shown here at the end. So some near miss events are shown on this slide. So on the left hand side, we see multiple near miss events between vehicles 6 and 0 at the intersection region over here. And this makes sense because in the report, we stated that the graph loses a bit of its structure around the intersection region. So hence why these sorts of near miss events would occur at intersection regions. So the second case over here is a near miss between vehicles 3 and 1. So vehicle 1 cuts in just behind vehicle 3 when it changes lanes right towards the end. This is quite dangerous since vehicle 3 was traveling quite fast. Um, vehicle 1 was traveling quite fast at the time. So it could have collided with vehicle 3 when it did so. So just there cuts in one node behind it. And finally, on the right-hand side, we see a one-dimensional near-miss case. So at the start of the animation, the speed of vehicle 2 was quite high compared to that of vehicle 0. And then it slows down its speed just enough such that it avoids a collision with vehicle 0. So we see that here. So the speed of this 15 meters per second, and it's decreasing as it goes on. So here are three cases which are neither a near miss nor a collision event. So this is just regular vehicle motion which was simulated using the original learned distribution. So if I let this simulation run, we see, so for example, vehicle 2 tries to leave the map at this exit, vehicles traveling along their lanes, and so on. Just some simulated data sets where I've included all vehicles and not just those involved in the crash events are shown here. So the ellipse is the region where we detect background vehicles for the Ego vehicle. So I've highlighted all background vehicles in green and all other vehicles in blue. And so here I've increased the frames per second. In the previous slides, they were quite low, just so that we can see the speeds of the vehicles and how they move just before the crash event. But this is like a smoother animation of vehicles. And finally, this is the animation of the actual vehicle behavior in the NGSIM dataset. So the left-hand side is the complete graph. And if we zoom into this intersection here, we see the vehicle behavior a lot more clearly. And these blue nodes is where the intersection begins. And finally, this is the animation for the round D dataset, just to show how vehicles would move on a roundabout graph. Just one thing to know about this. This here is a truck which was parked in this region in the actual dataset. That's not an error in the animation itself. So thank you for listening, and that's the end of this presentation.